All right, guys. So welcome back. The last 10 MCQs of this lecture of this paper, May June 2010, paper one, variant one, AS Chemistry 9701. All right. So let's get started from 31 to 40. The previous MCQs have been covered in the last three lectures. The links to which have been given in the description. Do check that out. All right, before viewing this lecture if you haven't. All right, so MCQ number 31. Which diagram represents the part of a giant molecular structure? They are talking about a giant molecular structure. Okay, from our syllabus, we know that diamond and silicon dioxide have a structure like this, a tetrahedral structure. All right, this is actually a structure of diamond because carbon atoms are there. All right, only carbon atoms are attached and a tetrahedral structure is present. And diamond does has a giant covalent structure, so A1 is correct, a giant covalent structure. Then what about number two? This is actually we can see the hexagonal rings, and this is again a carbon atom, allotrope of carbon atom. This is a structure of graphite, and this is also a giant molecular structure. One and two are correct. What about the third one? This is actually a giant ionic structure. This is not a molecular structure. This is an ionic structure. Three is not correct. So one and two only. One and two means B. 31 is B. Now let's move on to 32. Which reactions are redox reactions? Okay, for this question, we need to assign the oxidation numbers and see if there is any change in the oxidation numbers. Okay, bromine atom over here has the bromine molecule has zero oxidation charge number is zero, whereas over here it's -1. So there has been a change in oxidation number of bromine. So this is correct. This is a redox. What about the next one? Bromine is -1 and bromine is still -1. No change in the oxidation state of bromine. All right, so 2 is not correct then. If 1 is correct and 2 is not correct, then this means that 3 by default is also not correct because there is no combination in which 1 and 3 are correct. So if 2 is wrong and 1 is correct, 3 by default is incorrect, and so delta is the correct option. All right, let's move on to MCQ number 33. Sodium hydrogen sulfide, all right, NaSH, is used to remove hair from animal hides. Okay, which statement about this ion are correct? All right, let's see. It has 18 electrons. Okay, sulfur and hydrogen and SH, and it has a negative charge. All right, so how many electrons are present in hydrogen? We have one electron in hydrogen. How many electrons are there in sulfur? We have, since proton number of sulfur is 16, so it will sulfur atom will also have 16 electrons. One electron is present in the hydrogen atom, and this negative charge, it indicates that one extra electron has been added to it. So this makes a total of 18 electrons. So yes, one is correct. Three lone pairs of electrons surround the sulfur atom. All right, so if sulfur has this charge of, sorry, it has 16 electrons, so let's make out its structure. 16 electrons and it's present in group 6. Sulfur is in group 6. This means that it will have 6 electrons. 6 outermost electrons are present in sulfur. 1 2 3 4 and 5 6. All right, so let's assume that these are the 6 electrons. If it has shared one of its electrons with hydrogen's configuration is complete, and this extra electron must also have been added to the sulfur atom. All right, so if we now total up all the electrons which are present around it, how many lone pairs are there? This is actually a bonded pair. Okay, we are not going to consider this these two electrons with it. Actually, the structure looks something like this. Sulfur has a single bond with hydrogen. It has its own electrons, two electrons, and one electron is left in its outermost shell, because we know from theory that it has 6 electrons in its outermost shells, right? Now there is an overall negative charge on top of it. Negative charge means that an extra electron has also been added over here, and it has been added to sulfur. It can be added to sulfur. It cannot be added to hydrogen because hydrogen's duplet is already filled by the shared electrons. So now this extra electron is with sulfur, and so one lone pair, two lone pairs, and three lone pairs are present on sulfur. So yeah, this is also correct. Sulfur has an oxidation state of +2. Let's see. Okay, the oxidation state of hydrogen is always +1, and oxidation state of sulfur is what we don't know. Let's assume it to be x. X plus 1 is equals to -1. And if we rearrange this formula, okay, y equals -1 because the overall charge on it is -1. Okay, if we rearrange the formula, it becomes -2. It's not +2, it's -2, so 3 is not correct. 1 and 2 are correct, 3 is not correct. Bravo is the correct answer. B is the correct answer for 33. Let's move on to 34 now. When organic refuse decomposes in water, carboxylic acids are formed. Okay, the water becomes acidic and aquatic life is destroyed. What additives are suitable to remove this acid pollution? Okay, if this is an acid, we'll need basic additives. Calcium carbonate, yes, it is basic. It will react with the acid and will try neutralizing it. Calcium hydroxide can also neutralize the acid because it's basic. Potassium nitrate will have its own problems because it will introduce more nitrate ions into the water. This will lead to the process of eutrophication or algal bloom. Okay, eutrophication can occur due to the nitrate ions. It will lead to excessive growth of algae in water. So 3 cannot be the correct answer, and 1 and 2 are correct. So again, B is the correct option for MCQ number 34. Now let's look at MCQ number 35. In car engine, non-metallic element X forms this pollutant Y. Further oxidation of Y to Z occurs in the atmosphere. In further oxidation, 1 mole of Y reacts with half moles of gaseous oxygen. What can X be? All right. So basically, they're telling us that X forms this oxide Y. So X actually reacts with oxygen to form Y. And then after reacting with oxygen to form Y, this is actually a pollutant oxide. Okay. This cannot be carbon dioxide because carbon dioxide is not a pollutant, but it can be carbon monoxide or it can be oxides of nitrogen. All right, so let's see. Now, after this Y has been formed, Y can also be oxidized to Z. All right, and in this further oxidation, 1 mole of Y requires half moles of oxygen are needed. Okay, let's try out these answer options. Okay, what about carbon? Okay, carbon if burns in oxygen, it can form carbon dioxide. A non-metallic element X forms a pollutant oxide Y. And okay, so if we look at the first option over here, it's carbon atom. Carbon atom can burn in oxygen to form the pollutant oxide carbon monoxide. Carbon monoxide is a pollutant oxide if incomplete combustion occurs. Okay, if incomplete combustion occurs in of this element X and forms this pollutant oxide Y. But guys, one thing to note over here is that this carbon monoxide, although it does require half mole of gaseous oxygen, 1 mole requires half moles, but this oxidation, this reaction does not occur in the atmosphere. This does not occur to form carbon dioxide. Carbon dioxide that has been formed, it is not a pollutant oxide now. This is a non-pollutant oxide. This is not a pollutant oxide that has formed. And this reaction actually does not occur in the atmosphere very easily because carbon monoxide by itself is pretty stable in the atmosphere. Whereas, so 1 cannot be the answer because this carbon monoxide, although we know that yes, 1 mole does require half mole of oxygen to form carbon dioxide, but this reaction does not occur in the atmosphere. It does not occur in the atmosphere because carbon monoxide stays as carbon monoxide due to its high stability. Carbon monoxide is stable in this form, so it does not easily convert into carbon dioxide. Whereas if we compare the oxides of nitrogen and sulfur, yes, they do. Nitrogen first forms nitric oxide and then nitric oxide quickly converts into nitrogen dioxide. Sulfur also forms sulfur dioxide and it is then oxidized to sulfur trioxide in the atmosphere. So 2 and 3 are correct, but 1 is not correct. So C is the correct option. Now let's look at the next MCQ 36. Sulfur dioxide and sulfides are used in food preservation. Okay, what are they used? Why are they used for this purpose? Okay, sulfur dioxide actually it is used to kill germs. Okay, and they are reducing agents. Yes, sulfur dioxide is reducing agent, so it actually prevents the oxidation of food. Yeah, then they inhibit the growth of aerobic bacteria. Yes, that's also correct. They react with nitrogen dioxide, converting it into nitric oxide. Well, this sulfides and sulfur dioxides are added to food. They are not added so that the nitric or nitrogen dioxide can be converted into nitrogen monoxide, but they are rather added for the food's production, protection and preservation. So they are acting as preservatives. So 1 and 2 only are correct. 3 is not correct. 3 is not the purpose for which these are added to food. So B is the correct option. 1 and 2 only. Now 37. Propanoic acid occurs naturally as a result of bacterial fermentation of milk and is partly responsible for the flavor of Swiss cheese. Okay, this is your propanoic acid. When which starting materials could be used to synthesize propanoic acid? All right, so how can propanoic acid be synthesized? Okay, if you look at the first MCQ, it's propanol. Yes, propanol can be oxidized. This is a primary alcohol, and oxidation of primary alcohols give you carboxylic acids of the same carbon atoms. Okay, so yes, one is correct. What about the second option? Second is a nitrile, and yes, nitriles can be hydrolyzed. Hydrolysis of nitriles give you carboxylic acids as well. So 2 is also correct. What about the third one? Third one is an aldehyde, and yes, aldehydes can also be oxidized. Oxidation of aldehydes gives us carboxylic acid as well. So 1, 2, and 3, all three are correct, meaning A is the correct answer. Moving on to the next MCQ. 38. Which structural formula represent 2,2-dimethyl pentane? All right, let's try drawing it out. Okay, pentane means 5 carbons. So 1, 2, 3, 4, 5. 2 comma 2 dimethyl means that the 2 carbon atoms, 2 methyl groups are on the same carbon atom, and which is at the second position. Let's assume that this is first, second, third, fourth, and fifth carbon. This is the longest chain. So 2 methyls are attached on the second carbon. Now, let's try matching these structures with the one that we've drawn. Okay, let's look at the first one. The first one says, okay, this is also going to be a methyl group then. Okay, so now in this carbon atom has 2 methyl groups. Well, and 2 methyl groups on this side, 1 and 2. 1, 2, and 3. We actually have 3 methyl groups attached to it. So A cannot be the answer. 1 cannot be the answer. Sorry, 1 cannot be the answer because this carbon atom actually has 3 methyl groups, not 2 methyl groups. All right, and plus 2, 3, 4, 5, 6, 7. It doesn't even have 5 carbon atoms. Actually, 5 carbon atoms, 6, 7, 7. Okay, carbon atoms are correct, but the arrangement is not correct. The second carbon must have 3 methyl groups attached to it. Okay, it must have 3 methyl groups. It's not okay. So if one is wrong, by default 2 and 3 are correct, and C is the correct answer. Okay, 39. Let's move on to the second last MCQ of this paper. Okay, 39 says which reactions are examples of nucleophilic substitutions. Okay, if you look at the first one, bromine is a nucleophile. Nucleophile is any species with at least one lone pair. And OH negative is reacting with it and it is replacing it. It is substituting it. So one nucleophile replaces the other nucleophile. So yes, one is correct. What about the second one? Okay, water is also a nucleophile because it contains lone pairs. And again, this is nucleophilic substitution reaction because iodine itself is also a nucleophile, contains lone pairs, and is substituted by the water molecule and then forms an alcohol. This is again a reaction directly from our syllabus. And then what about ammonia? Ammonia is also a nucleophile and forms an amine group. This is also something we've done in theory part. This is also included in our syllabus, directly from the syllabus. So 1, 2, and 3, all three are correct. A is the correct option. Now let's move on to the last MCQ. 40. All right. The diagram shows some laboratory apparatus. Okay, laboratory apparatus has been drawn over here. Which preparation could this apparatus be used for? All right. The first one says that bromoethane from ethanol, sodium bromohydride, and concentrated sulfuric acid. All right. Bromoethane from ethanol and this thing. Okay. And sodium bromide and all right. So now let's try. Let's draw out the structure of ethanol and then react sodium bromide with it and concentrated sulfuric acid. Okay, now sodium bromide and concentrated sulfuric acid, what does this hint us? Sodium bromide and concentrated sulfuric acid, they'll both react to give us bromine gas, and this bromine gas will go and react with, actually no, not bromine gas, This will form HBr in situ. This will form HBr in during the reaction. That HBr is enough for the reaction with ethanol. Okay, nucleophilic substitution HBr is strong enough to replace the OH group with a bromine atom. So now over here, this reaction is possible because we need concentrated sulfuric acid, sodium bromide both in here, and then this ethanol as well over here. So once this reaction occurs, HBr and ethanol, since this is actually providing it a lot of heat, so they'll be vaporized, and in the vaporized form, and actually this reaction, first reaction is possible. Okay, it is possible because H2SO4 and sodium bromide will first react in this round bottom flask. After reaction, they'll form gaseous HBr. Okay, gaseous HBr, and since we also know that ethanol is also volatile, so it will also have converted into a gas. Now these gases will react with one another, forming the product, and then this product would get condensed and will be collected in this flask over here. All right, so one is correct. What about the second one? Ethanol, this aldehyde from ethanol and sodium dichromate and concentrated sulfuric acid. Again, ethanol is, as I told you, it is a volatile substance, and dichromate is an oxidizing agent. So yes, ethanol will get oxidized to, sorry, ethanol will get oxidized to ethanal, all right, CH3, CH2OH, it will get oxidized to ethanal, all right, just by heating it with sulfuric acid. Basically, sulfuric acid is added to acidified the dichromate, all right, K2Cr2O7 is acidified. From theory, if we review this equation, alcohols, primary alcohols, when react with uh, K2Cr2O7 and are just heated, only heat, okay, not under reflux, but rather just heated, they'll form aldehydes. And so, since due to this aldehyde would have been formed, and then it, since it would have been volatile, so it will be collected separately, right? So this reaction will occur. This won't allow it to reflux because no reflux condenser is present in here, right? So two is also correct. What about three? The third one says that 1,2-dibromoethane from bromine and ethene. Actually, bromine and ethene, this is a kind of a direct reaction. Ethene is an alkene, and bromine will react with it. This is an electrophilic addition reaction, and electrophilic addition reactions do not require heat. They occur spontaneously in the dark. Okay, they'll occur quickly. They won't require any heat. So three is not correct. All right, so one and two are correct. So if three is wrong and the remaining are correct, so it's bravo, right? We know that one is right and third is wrong. The second one must have to be correct according. Sorry, second was is correct. So, it is actually correct because ethanol is formed from ethanol and dichromate in such an apparatus as well. Yeah, B is correct. So that's it. Thank you so much, guys. This paper is complete. May June 2010, variant one. All right. So thank you so much. In the next lecture, the link to the next lecture has been given in the description. Do check that out.